A researcher gives a memory test to 200 students. She gets 200 numbers. Now what? Statistics transforms raw data into meaning. Here is how psychologists make sense of numbers. The mean is the arithmetic average. Add all scores and divide by the number of scores. It is the most common measure of central tendency, but is sensitive to extreme values called outliers, which can pull the mean away from the typical score. The median is the middle value when scores are arranged in order. If there is an even number of scores, average the two middle values. The median is resistant to outliers, making it better for skewed distributions like income data. The mode is the most frequently occurring value in a dataset. A distribution can have no mode, one mode, unimodal, two modes, bimodal, or many modes. The mode is the only measure of central tendency that applies to categorical data. Choosing the right measure matters. Use the mean for symmetric distributions without outliers. Use the median when data is skewed or contains outliers. Use the mode for categorical data or to describe the most common category. The range is the simplest measure of variability. Subtract the lowest score from the highest. The range tells you the spread of data, but is highly sensitive to outliers. One extreme value changes the range dramatically. Variance measures the average squared deviation from the mean. It tells you how spread out scores are. Squaring the deviations eliminates negative values and emphasizes large deviations. However, variance is in squared units, making it hard to interpret directly. Standard deviation is the square root of variance, returning to the original units. A small standard deviation means scores cluster tightly around the mean. A large standard deviation means scores are widely spread. Most AP exam data questions involve standard deviation. Standard deviation matters for interpretation. A score of 70 on an exam with a mean of 65 and SD of 2 is very high. The same score with SD of 20 is barely above average. Context is everything when reading a single data point. The normal distribution is a symmetric bell-shaped curve where the mean, median, and mode all coincide at the center. Most psychological traits, including IQ, personality scores, and reaction times, approximate a normal distribution in large samples. The 68-95-99.7 rule states that in a normal distribution, 68% of scores fall within one standard deviation of the mean, 95% within 2, and 99.7% within 3. This is called the empirical rule. A z-score expresses how many standard deviations a score is above or below the mean. A z-score of 0 means the score equals the mean. A z-score of +2 means 2 standard deviations above average. Z-scores allow comparison across different scales. Skewed distributions are asymmetric. Positive skew has a tail pulling right and a mean greater than the median. Negative skew has a tail pulling left and a mean less than the median. Income in most countries is positively skewed. Statistical significance answers whether a result is likely due to chance. A p-value below 0.05 means there is less than a 5% probability that the result occurred by random chance alone. Psychologists use this threshold by convention. A type 1 error, also called a false positive, occurs when a researcher concludes there is an effect when there is none. A type 2 error, a false negative, occurs when a real effect is missed. Lowering the p-value threshold reduces type 1 errors, but increases type 2. Effect size measures the magnitude of a difference, not just whether it is statistically significant. Cohen's d is the most common effect size measure. Small is 0.2, medium is 0.5, and large is 0.8. A study can be statistically significant but practically meaningless. With very large samples, even tiny meaningless differences become statistically significant. A drug that lowers blood pressure by 0.1 millimeters might be significant in 100,000 patients, but offer no practical benefit. Always ask about effect size, not just significance.